So now I'm going to talk about the how to manage your SAS output using the option statement. So you can specify the line size, page size, and display of page numbers, and the display of date and time. So I think this is particularly useful when you have the desktop SAS version. So by default, the page numbers and dates appear with output. And then with the following option statement, suppress the printing on both pages and date and time and listing output. So you can put option with no number and no date, then you ask SAS to not print the number and the date. And page no option is if you print the page numbers, you can specify the beginning page of number for your report. If you do not specify the page number, the output is the just start with the page 1. And then this example, so we specify the page number is equal to 3, and then suppress the date and number printing. And then you can specify the page size option. So this option specifies how many lines in each page of output contains. So in this options, number page size equal to 15. So we tell SAS to print out the 15 lines in each page of output. And the line size specifies the width of the print line in procedure. So if you have this example, line size with 86, then we have the limit of the 86 characters in each line. Then if it surpasses the 86 characters, then the observation continue on the subsequent page. Then we have the excuse me, this ODS system, which is called the output delivery system statements to generate HTML output. Actually, this is this ODS output delivery system is the default in the SAS. So this ODS statement, you do not need to put the ODS statement but for example, I will put the ODS statement here. So for example, if you run this one, so this result is the already ODS output. But if you go to your SAS files, then we create this print.example on here, which is the HTML format. Which HTML format, and which is the ODS output. I mean, this statement was quite useful when the ODS output was optional. I mean, but if now this ODS output is default in the SAS program, so this statement is not very useful. But I mean, if you know this, then I think it's. I mean, it is good to. It is a. I think, but even though it's not very useful as before, but I think it's still useful. Okay, so the part 4 we look at how to manage the variables. So create the accumulate the variables with using the sum statement. The syntax of the sum statement is that, by the way, the sum statement and the dataset create the variable that cumulative sums of another variable. So we have sum variable plus the expression is that sum variable specifies name of the accumulated variable. And the expression can be any valid SAS expression, like a numerical variable. For example, you would like to find the total of the average 10 students in the dataset HS grade. We define the sum variable sum score whose the value begins at 0 and increases by amount of existing variable score average in each observation. So now, if you look at this code, so we have score average. And here now we define the sum score, which is the accumulating the value of the score average. Excuse me. By score average is the average of the 5 subjects. So this one. So it starts with the ID 1. And then it accumulates the score average going over the observation. So for example, if you look at this output, so we have sum score as the 55.2 for the first observation. So here the sum score is equal to 0 plus score average for observation, so that sum score is 55.2, and then score average is this. So here for observation 2 is the 36.0, so now it's going to be 91.2, and then for the third observation, the score average is 42.4, and then we add this 94.2 plus the 42.4, then you get the 133.6 and etc. So by using this sum statement adds the result of the variable to the score average to the accumulated variable of the sum score. And then you can initialize the sum variables by using the retain statement. So by using retain statement, you can specify the initial value. So here, if you this code, so this retain statement, we specify variable, the variable that you want to specify the initial value. The initial value is the initial value. So in this example, we put the retain statement before the sum score, the sum statement. So we have retain sum score equal to 100, which means that our sum score starts with 100. So now let's look at the output. So now the first observation's sum score of the first observation is the 155.2. So which is the 100 plus 55.2. Which is 155.2, and then for second observation, the sum score is 191.2, which is sum of 155.2 plus 36.0, and etc. So the values of sum score changes so this compared to the previous code. So our sum score is plus 100 because we start the sum score equal to 100. And then here we have the now I'm going to talk about if then and else statement. So here if then statement is this very similar to the if statement in R. So you have a logical expression in the if, and then we put the then. So if this expression is true, then it implements the statement after the then. So for example, if we want to create a binary variable pass, then assign the variable yes to variable pass when the score average greater than or equal to 50. So we can make an if statement. If score average greater or equal to 50, then pass, we create a new variable pass equal to yes. Then we don't have any statement for the false case. So if you look at that, the score average greater than 50, greater than equal to 50, then we have a pass yes. But if score average less than 50, we don't have any result. So this is the this is missing. So and then the so for the logical comparison and logical operators, so if you write the if-then statements, you can use any comparison operators. So you have equal to, equal, or EQ. So is the here equal is the it's different from R, so we just use the single equal. Not equal is you put hat and equal. Greater and less than is the same as the R, and greater and equal to, less than equal to is the same as the R. You can specify in statement which is equal to one of the list. So you can, for example, you can specify test less than 85 and time is less than or equal to 20, then state test equal to retest, and the region is in if your region category variable is has the category in one of the NE, NW, SW, then rate is equal to fee minus 25, and target is greater or equal to 30, or sales is greater or equal to 50,000, then bonus is equal to salary times 0.05. Then you have the AND logical operators, which is similar to R, AND, or, and not statement. So as in the R, so use the AND operator to execute the then state after the statement after then if the both expressions are linked by AND and they are true. So status is okay and type is 3 if both conditions are satisfied. Then we implement count plus 1. If age is not equal to age check and error is equal to 1. So we execute the statement test equal to 1 if both statements are satisfied. And or operators is the even just one of them is satisfied, then we specify test equal to 1. And for not operator, each operator is the reverse of the logical of the comparison. So logical hours less than 705,000 is not. So which means that log hours greater or equal to 7,500. Then we say in schedule is the quarterly. So if region is not on NE and SC, so let's say region is belong to NW, then we put the bonus equal to 200. So the character values must be specified in the same case in the way they appear in the data set, and they should have the quotation mark. So if I have status is okay, then if your data set is a lowercase okay, then it does not implement. And we should have this quotation mark on here for the character values. And then, so this is the order of execution. So here we have AND and OR, and then we have a parenthesis in here. Then we first implement within the parenthesis. So we evaluate first OR, then evaluate the second and AND. So if you want to evaluate the first argument and evaluate the if you have the preference in your execution of the statement, then you can put you need to put the parenthesis to make a preference. And then in SAS, any numeric value other than the 0 or missing is true, and the value of 0 or missing is false. So if you say 0 or missing, that's a false, and if you say 2 and 3 in the logical evaluation, that's a true. So you need to be careful using the OR operator in a series of comparisons. And then, so for example, for OR operation, either one of them is true, then it's okay. And then non-missing constant is always evaluated true. So for example, if you say x equal to 1, or then if you miss x equal, and you just say true, then so SAS first evaluate x equal to 1, and even though this is false, there is a 2 here, so that SAS says, okay, so I have a 2 on with OR statement, so this statement is true, even though x equal to 1 is false. So to have the precise argument, you put the x equal to 1 for OR x equal to 2 to make your statement more precise. Okay, so I will talk about the more about if and then in the next video.